In the last few videos, we've seen examples of time domain waveforms. That is, voltage or current or power plotted against time. This is a very common way to visualize a signal, and it's what we see on a display of an instrument called an oscilloscope, which is one of the most common electronic test instruments. However, there is another method called the frequency domain. Here, we plot frequency on the x-axis and amplitude on the y-axis. So, to take for example a sine wave, have a look at the diagram below. Where this comes in handy is if you have a very complex signal and you would like to see which frequencies it contains. An instrument is available which measures and displays this directly, called a spectrum analyzer. And the frequency domain representation of a signal is sometimes called its spectrum. In mathematics, there is an operation which can convert the time domain to the frequency domain called the Fourier transform. And the inverse Fourier transform converts the frequency domain back to the time domain. It can also be shown that any periodic waveform, you'll remember that that's a waveform which repeats itself, can be synthesized by adding a series of sine waves together. Take for example a square wave. We start off with a sine wave at the frequency that we want. Then we add another sine wave, this time at 3 times the frequency but only 1/3 of the amplitude. Next add another at 5 times the frequency and 1/5 of the amplitude. If we keep on doing this, the next signal being 7 times the frequency and 1/7 of the amplitude, you would eventually produce a square wave. The first sine wave present is called the fundamental, and the higher ones are called the harmonics. But notice how in complex cases like this, the frequency domain makes the content of the signal easier to visualize than the time domain.